Today, we're continuing down the path of exploring building intelligent applications with AI in the Java world, specifically with Spring AI. Now, in a previous video, we talked about the ability to kind of add some context to our prompts. Now, why would you want to do this? Well, LLMs have a very specific cutoff date of their training data, so it might not be up to date to be able to provide the right or correct answers to a specific query. Now, we talked about some different options there when it comes to stuffing the prompt or RAG or functions. And we looked at an example of being able to stuff the prompt or add some context to the prompt as we send it off to the LLM. So if you're curious about that, check out that video. I'll leave it up here and in the description below. I want to take this one step further today because in that example, we just had a little bit of text that we added to the context. What happens if we have a lot of text that we want to add to the context? We know that tokens are the currency of LLM. So if we had a 1,000-page PDF, we wouldn't want to stuff the prompt with 1,000 pages of a PDF document every single time we made a call to the LLM. That is going to get very expensive. Instead, what we want to do is we want to find a way to query that PDF and say, okay, based on whatever the prompt is, whatever the user's query is, let's pick out the relevant bits of that PDF and send that along as context. And that's what we're going to do today as we talk about something called Retrieval Augmented Generation, or RAG for short. And this is the ability to take textual documentation, our PDF, our text files, and break them down into a vector database. We'll talk more about vectors and embeddings in a second. But now we can query that and pull out the relevant bits and send that along as context. So here's what we're going to do. I want to start at the documentation so you know where to look for some of this information and read up on it a little bit more. We'll talk about it at a high level. And then we'll create an application based on RAG using a vector database, and we'll see how this all kind of comes together. So here we are at spring.io. I am going to go to projects and all projects and come down to Spring AI. I'm going to go into the learn section and go into the reference documentation. So if we go under Spring AI API, we can see a couple of different things. Now we talked about vector databases. So what is a vector database? How is it different than the databases that we're used to using, right? A vector database is a specialized type of database that plays an essential role in AI applications. In vector databases, queries different from traditional relational databases. Instead of exact matches, they perform similarity searches. When given a vector as a query, a vector database returns vectors that are similar to the query vector. Now, this is the important part. A vector database stores vectors, not text. Vectors, there's some mathematical science behind this that I'm not going to pretend to understand, but we'll see an example of what is actually getting stored in a vector database today. So that's a vector database at a high level. Again, start to do a little bit more research into this. You can read through this. Here's the important part. There are a bunch of available implementations in Spring AI. You can see the list here. In a future video, we'll look at like PG Vector Store, which I'm a big fan of. There's a lot of great options here. I know my friend Craig Walls is a big fan of Chroma Vector Store. Neo4j is there, so a bunch. There is one here, though, called the Simple Vector Store, a simple implementation of persistent vector store, good for educational purposes, and that's what we're doing today, educational purposes. So we'll take a simple vector store, which can just be a JSON file, and we'll see how this works. Again, we're slowly building, using the building blocks of kind of moving to the next step. Again, next step in the next video, we'll use a PG vector store and continue this on. So those are the implementations. Now, here's where it gets a little tricky, right? Dan, you just told me that vector stores store vectors. I don't have vectors. I have PDFs and text, right? And that's where the embedding APIs come in. So an embedding client, there's an interface designed for straightforward integration with embedding models in AI and machine learning. Its primary function is to convert text into numerical vectors, commonly referred to as embeddings. So I hope some of the pieces of the puzzle are starting to come together here. We have a vector database that needs to store vectors. How do we take our PDFs or our text files and turn them into vectors? The Embeddings API. So if you hear vectors, Sometimes you'll hear them referred to as embeddings. This is a really good place to start. So you want to dig through here, take a look at this. There's an interface called the embedding client. That's good to know what's in there. But there are also some implementations of this. So as we are working with OpenAI, there is an OpenAI embeddings. So again, if you're working with this one specifically, you'll want to look through here. There are properties that you can configure. Again, I don't want to overwhelm you, so we're not going to go in there. I just wanted to leave you with the documentation. So after this, if you want to explore this further, you know where to look. So what we're going to do today is build a new application. We're going to select Maven. We're going to select the latest version of Spring Boot. I'm going to say dev.dan Vega. We're going to call this FAQ. If you were with me in the last one, we did a stuffing the prompt kind of exercise. And we did it on the 2024 Paris Olympics. I want to continue that. On that same website, I found a whole bunch of FAQs about the Olympics. I'm going to use that document as something that we can provide our own data to, because something like OpenAI does not have access to that documentation yet, unless it was published way long ago, but I don't think it was. So we're going to say FAQ. We're going to use Java 21. Like we've been doing, all we need is love. No, all we need is a web dependency, and we need the OpenAI. So I'm going to choose OpenAI. With that, I think we have everything we need to get a little dangerous. So let's go ahead and generate that, which is going to create a zip file. You can go ahead and download that and open it up in your favorite text editor or IDE. I'm going to open it up in IntelliJ Ultimate Edition. And with that, let's write some code. All right, so I have my application open up in my IDE. The first thing that I'm going to do is go ahead and take a look at application.properties as I've been doing. If you missed my introduction to Spring AI, you want to go back and watch that. But I have two properties here. The API key for OpenAI, I am storing in an environment variable so that I do not leak that when I publish this to GitHub. And then we're just defining the model. You can use something like GPT 3.5 Turbo. I'm using GPT 4, so I'm just kind of declaring that here. So with that, we have everything we need to talk to OpenAI. So I want to start with the document, and this is going to be the document that we are going to query to get some context to send to the LLM. So I'm going to create a directory here called docs. And inside of docs, I am going to paste the doc that I have called the Olympic FAQ. Now you can pull this down from the repo if you want to follow along. I pulled this off of the 2024 Olympic Games in Paris website. Just has a bunch of question and answers, right? Again, things that may not be able to be answered before based on the cutoff date of the LLM's training data. So we have an FAQ. Now this could easily be yours, right? You could have a whole bunch of text that you're providing, maybe a PDF, but the PDF will be a little bit different. We'll go over how to kind of split up a PDF in the next tutorial, but in this one, I just have a text file. So this is the text that we're bringing to the table. Now we need to kind of set some things up. So I'm going to start with a class called the RAG configuration. Again, we talked about it in the beginning. The feature that we're kind of using to help us add some context here is called Retrieval Augmented Generation, or RAG for short. So I'm going to call this my RAG configuration. And this is going to be a component, but it's also going to be a configuration class. So we're going to mark this as a configuration class. And then we're going to do a couple of things. First, I need a logger. I have this little shortcut here in my IDE to kind of print out or create a logger for me. So I have a logger that I can use. The next thing I need is access to that document that we just created, right? So I'm going to use the @value annotation and say this is in the class path, and this is located in the docs folder. And we named this Olympic FAQ.txt. So we'll assign this to a resource. So resource, yep, and we'll just call this FAQ. All right, so now we need to go ahead and create a bean. That's why we made this as a configuration class. I'm going to create a bean. Now remember, I said we are going to use a vector store today, and there are many implementations of a vector store, one of which is a simple vector store. So simple vector store. And then we talked about the embeddings clients. These are how we can kind of split our text or PDFs into vectors to store in our vector database. So I'm going to get an embedding client, and there's my embedding client. Now, this is the simple vector store. Again, from an embedding client standpoint, this is an interface, but because we have OpenAI on the class path, Spring AI has configured an OpenAI embedding client, and that is the one it will choose, and it will automatically wire this in for us. So what we need to do is we need to create a simple vector store. We need to say new simple vector store. And if we look at the API for this, this takes an embedding client. So we need to pass that embedding client in. So I'll pass that embedding client in, and I'll get a variable from that, and we will call that simple vector store. Okay, next what we need to do is we need to get our vector store. Now, a vector store in this case is just a simple one. It is going to be a JSON file. So let's go ahead and create a directory here called data. I am going to, let's do this. Let's say private file. This is going to say get vector store file, right? And what I need to do is I'm not going to create this as a resource because the very first time that we start this up, that file may not exist. So I don't have access to be able to get the URI of that file. So I'm going to use some Java here to help me. I'm going to say paths.get, and I'm going to say source main resources data, and that is going to return us the paths, right? So from the paths, I can say, give me the absolute path to that file. So I'm going to say path.toFile. And what is the file? We are going to use, let's say, get absolute path. The absolute path will put us into source main resources data. And I'm just going to say +/+ and then we need an actual file name. So let's actually configure that. So I will say, let's get an @value annotation, and we'll just kind of configure this. Actually, let's just do this. Let's say private final string vector store name. Yeah, I have no problem storing this because we could always configure this later. I'm gonna just say vector store.json, and that's our vector store name. Oops, Dan. Okay, with that, I can say vector store name. Probably didn't need to do that, but that's okay. Let's say .var. This is going to be the absolute path. And this is going to be a string. We'll just say string absolute path, right? So that should work. Okay, and then from that, I can just say return a new file. And that file is going to use the absolute path. So that returns a file, which means we can come up here now and say get vector store file, create a variable from that, and we will call that vector store file. That looks good. Okay, so now we have our vector store file. We want to just make sure it exists just to be good citizens here. I'm going to say if vector store file.exists, which it should, well, which it may not, right? So the reason I'm doing this is because I don't want to load this vector store database every single time. We just want to do this once. We don't need to do this every single time. So we're doing this check to make sure that, hey, if it exists, that file already exists. We can go ahead and load it. We don't need to do all the things we need to do to kind of split our text up into vectors using the embeddings and then save those into there. It's already there. We can just simply load it up. So we can go ahead and say, I'm going to go ahead and add a log statement here and say log.info and just say vector store file does not exist. Vector store file exists. Sorry. Right? So that's all we need there. And then we can just say, hey, simple vector store dot load, and then load from that vector store file, right? So now the simple vector store is loading that vector file. Else, what do we need to do? We need to, let's just log that out so we're sure. Right, so now we need to log, in this scenario, we need to like read from the text document, find a way to create these embeddings and save them into our vector store. And then we can go ahead and return it. So at the end of the day, what we're returning is a simple vector store that we created here. And again, this is a bean that is returning a simple vector store. So that's our return statement. So let's talk about how to make this happen. So the first thing that we need is we need a way to read in that FAQ. And it turns out we have a way to do that. There is a text reader. So if we look at text reader, there's a couple. One takes in a string, one takes in a resource. So as we see, we can take in a string or a resource here. So in this case, I can say I'm just going to pass in my FAQ. That is a resource. So from there, get a variable for that, and I'll call that text reader. So now that we have a text reader, we can say text reader dot get custom metadata about that particular text. And I want you to go ahead and put the file name Olympic FAQ.txt, right? So we're just adding some custom metadata there. Now what we can do is we can use the text reader to basically get the information from the text file. So we can say text reader.get, and what is that going to return us? That will return to us a list of documents. Now, what are documents? So we look at this. This is under Spring Framework AI document. A document is a container for the content and metadata of a document. It also contains the document's unique ID and an optional embedding. Okay, so now that we have the documents, we need a way to kind of split those up. So I'm going to create a new token text splitter. We'll say var text splitter. Yeah, let's just call it text splitter. And using the text splitter, we can say apply, and we can pass in our documents. So that will go ahead and return to us our split documents, right? So now we have our documents that are split up. So let's just look at what this does. So if we look at apply, we can see that this returns to us a list of documents. It takes in and basically splits them up for us. So we have our list of documents. These are called our split documents. Now we can use our vector store. We can say, simple vector store, I need you to do two things for me. First, I want to add my documents. So these are the split documents. And simple vector store, I need you to go ahead and save this for me. So save the vector store file. That is our vector store database, if you will. So before we do anything with this, I just want to make sure that this works, right? So hopefully what happens when we go ahead and launch our application, this is a configuration class that'll get picked up. This bean will be created. This goes through and it creates a simple vector store. The file that we're going to use is in in source main resources data vector store.json. So there's nothing there now. So it does not exist. So what should happen is it's going to read that text file in. It's going to split them into documents. It's going to save those documents and save it to the vector database, which is our simple vector store. So let's see if everything works. And it does. We can see that vector store was created. So if we go back up here, we can reload this from disk and we see a vector store. So again, this is creating those embeddings that we know nothing about, right? This is all like kind of mathematical precision, being able to know like how it's storing stuff. So it's storing stuff as vectors. You can see the embeddings, you can see the content. There's some metadata here that we added, the file name. So this is at a simple form what a vector database looks like, right? It stores all these embeddings. But what this tells me now is we have a vector database that we can search against. So we've added our documentation, we've stored it in a vector database. Now we can start to query that vector database, or vector store in this case, and do some searching to find the context that we need to go off and send to the LLM. All right, so I'm going to paste in a prompt here. We've talked about this before. I'm kind of externalizing the prompt that I'm going to use here into something called RAG prompt template. You are a helpful assistant conversing with a user about the subjects contained in this set of documents. Use the information from the document section to provide accurate answers. If you are unsure about the answer that's found in the document section, simply state that you don't know the answer. So here's our question. Here's the documents we're, again, providing context for. So I have my RAG configuration, and just to kind of point something out, if we do this again, you won't see that vector store getting created. It's already been created. That is not something you want to do every time your application starts up. It's really kind of anytime you need to kind of update that information. So I'm going to create a new class, and I'm going to call this the FAQ controller. This is going to be a REST controller. This is going, actually, I think we only need one mapping. So we need a chat client. We've done this before. So we're going to go ahead and create a chat client. Chat client. We'll get this through constructor injection. And now we can start to work our magic. So just to spare you a little bit of typing, I'm going to paste this in here and we'll take a look at it. So the first thing that we have is this FAQ. It takes in a request parameter. This is the message that we're going to feed to it. How can I buy tickets for the Olympic Games in Paris? We're going to assign that to a message. So the first thing we need to work with is a vector store. So I'm going to get an instance of a vector store. I'm just going to say private, final, vector store, vector store. This is going to be given to us through dependency injection because we created one in that configuration class. It's a simple vector store, but a simple vector store is a vector store. So now we have a vector store to work with. One more thing I'm going to need is the RAG template that we just created, that prompt template. So I'm going to say at value in here, I'm going to say class path. This was in prompts. And what did we call it? I think RAG prompt template.st, right? And we'll assign this to a resource called RAG prompt template. Okay, so what we're doing using the vector store database here is we're doing something called a similarity search. You'll remember from the documentation that this works differently than talking to, say, on a relational databases. It's using the math to find similar vectors based on our query. And our query here is the message. How can I buy tickets for the Olympic Games in Paris in 2024? So there's also some options that you can give it. With this one, we're using with top 2 of 2. So we have our similar documents. So from our similar documents, we can now turn that into a stream and map them based on the document's get contents to a list. So now we have basically a list of content, basically the context that we want to send with the prompt. So we have this prompt template. We saw this before. If we go back in here and look at this, I just want to remind you that in the prompt template, there's an input and there are documents. Those two things are the things we want to fill in. So we create a map and we provide the input, which is the question, the message that we're asking. We provide the documents, which is that content list. And from the content list, we're basically saying, hey, go ahead and join those on the delimiter of a line break, right? So we're putting those documents into the prompt. So we create a prompt. We say, hey, create a prompt from those prompt parameters there. Now we can do the thing that we've been doing all this time on this channel in the different Spring AI presentations that I've gone through. And that's use the chat client to call. Using the prompt, we're going to get the result, get the output, and the content is the actual string response. So that's why I'm using string here. And again, if you missed it, we've done a video on output parsers. So an output parser is a way to not just get a string back. Maybe you want to map this to a specific type of object. You can use a map, a list, or some type of bean, maybe a record in your system. In this case, I just want to take a look at the response as a string, but this should work. So let's see if this works. If this works, we should be able to go to localhost 8080/FAQ, and it will use this default question, but we can also provide our own question. So maybe we'll do that as well. So let's see if this starts up. All right, everything's looking good. We're going to go into our terminal, and we are going to say HTTP. Again, if you're new to this channel, I use a program called HTTP-IE. If you have curl, you can use curl. You can use something like Postman to test this out. But I'm just making a GET request to localhost 8080 and /FAQ. Looks like it's thinking, taking that context, sending it off to the LLM. And here it is. Tickets for the Olympic Games in Paris can be purchased on the official ticketing website. Additionally, the Paris, blah, blah, blah. I'm not going to read the whole thing for you. So it knew how to answer that question, right? So let's see if we can ask it one more question. Let's go back into our docs and our FAQs. And let's see if we can do this. What sports are in the Olympic Games? So it has a list of all the sports that are in the Olympic Games. This is something we did in a previous video as well, but I'm going to mix this up a little bit. And I've actually never done this, so if this fails, that's okay. All right, let's look at our controller, and we take something in called a message. So I'm going to say I'm asking the FAQ for a message, and I'm going to say how many sports are included in the 2024 Olympics. So let's see if it knows based on that. It has all the sports. I wonder if it can go ahead and count it up for us so we don't have to count those up. All right, so the documents do not provide a specific number of sports included in the 2024 Olympics. However, the following sports are listed. So it includes all those sports, but no, it does not provide a count. That's a little surprising. I thought it would be able to go ahead and count those up. But on the flip side, if we wanted to get a specific type back, in this case, we talked about using output parsers, right? So we could turn this into a list of strings if we wanted to, and then easily be able to get a count on that. So again, just to review, we start with our RAG configuration. This is how we kind of load up our vector database based on the documents we want to provide it. I have a small one here. You can use large documents. You could use multiple documents. Let's load up our vector store with all of those relevant documents. And again, we're not just storing text, we're storing vectors, and the embedding client helps us with that. So once the application starts, we have our vector database. From there, we created this simple prompt that asks a question and provides documents if they are available. And then we went ahead and created a REST API that we can call that will do the similarity search against that vector database, get us the relevant bits out, and then kind of assign that to the context that we're sending to the LLM. So all in all, not a whole lot of moving parts, but again, this is next level from kind of stuffing the prompt. And really with this kind of format, you can do anything you need to do to provide context to the LLMs. Whew, that was a lot. There's a lot going on there, but we kind of compacted it into a nice little tutorial. So again, we use the simple vector store. You got to walk before you can run. I thought instead of like throwing more things at you as far as like having to set up a real vector database, maybe through like Docker Compose or something, that we'd start here. But we are going to do that in the next video, so stay tuned. Again, the whole point of this is the bring your own data. We can stuff the prompt. We can use RAG. We can use something called functions. This is being able to kind of augment, and it's part of the title, right? Retrieval Augmented Generation. Augment the prompt that we're sending so that we can get the right answers, because the LLM may not have all the answers. The training data is not there. Not access to your private documentation or product information. So I thought this was a lot of fun and a really good start, and really just the start. Like, we're going to have a lot more fun with this. Some of the questions I've gotten online are, Dan, this is great, but I really I need you to put this into like a full application so I can kind of see the big picture. And we're getting there. We are taking all these steps to understand some of the basics of AI, some of the basics of Spring AI. But as we start to put these pieces together, we're going to be able to do some really cool things. So I hope you can see that now, and I hope the wheels are turning and you're starting to think about some of the applications that you can build with Spring AI. So hey friends, if you found some value in this, do me a big favor, leave me a thumbs up, subscribe to the channel, and as always, happy coding.